Hi everyone. Uh, just let me know if you guys are able to see my screen, if we are live. Just check. You guys able to see my screen and hear me properly? Let me know if that is the case. I will start up with the question. Okay, great. I can see you guys are able to see my screen. So let's start off with the problems that were there in your contest today. Antique collections. So I'll take you directly to the question and let's have a look at this problem. So this definitely was an easy question. I'm sure a lot of you must have already done this, but let's see how can we solve it. Let's understand the question first of all. Geeky had developed a deep interest in antique items. This is some story. Let's come on the question. He created two arrays of size n called items and prices. Each item at index I, these are the items, and index I corresponding to that index in price array is the price corresponding to that item. So this first item number 1 has price 3, item number 2 has price 4, item number 2 can have price 5 also. That's what the question says. That I in the items array had a corresponding price at index I in the prices array. Okay. Can you help Geeky find his minimum budget to get all the different types of antique items from the market? So the question is that these are some items, right? These are, let's say, their items ID. Okay. And these are the prices associated with them. Now, what you have to do in this is that since these are the prices, one particular item ID can be sold by some other merchant at a different price. So if you are a buyer, your target will be to get an item, the same item for a lesser price, right? And you want to get all the different items. So in this item array, how many different distinct items do you have? So you have one, other item is 2, other item is 3. These are the distinct items and you want to get all of these 3 items. Now the problem here is that 2 is being sold for 2 different prices. One is 4, other one is 5. So as a buyer, I will choose that item with a lesser price. So what is the total amount that I will have to give to buy these 3 different items? So that will be 3 plus 4 plus 6. That's how I'm getting 13. You got it? So this is how you have to do this question. Now if I have only one item and I have its price, I will buy that item, the right? So that's about your problem. How can we solve this problem? Very easy. So what we are doing here is we are maintaining a hash map. So I don't need much to write also in this question. Just give me a second, but I'll tell you. So we have 1 2 2 3. These are the IDs, let's say, of the items, and their prices are 3 4 5 6. Okay, 3 4 5 6 are the prices. Now what I'm doing in this question is I want to know if there is a repetition of a product ID, then I want to choose the ID with a lesser amount, right? So that I have to pay less amount, right? So for that I will be creating a hash map so that I can store distinct key value pairs, right? Okay. So one question is, what is maximum vector size we can have? So the maximum vector size will be the total distinct IDs, product IDs that you have. I'll explain you. Let's have a look here. So if, let's say, this is my map. Okay, this is my map. I have this one. So the key value pair will be, key will be your ID. Okay, and value will be the price of that ID. Fine. That's how you are going to store your hash map with. So when you ask, you are iterate over this IDs. Okay, ask for the ID 0. This is ID 0. ID 0 is 1. Does your map contain this ID 0? No. So you will add a pair with key 1 and value will be its price. So 1 3 is what you are storing in your hash map. Okay. Next is okay, I'll just continue with the explanation, then I'll come at your doubt at hashtag tag. Okay, then I come at ID 1. This is 2. Do I have a key with 2 in my hash map? No. So I will store 2. And what is its price? Its price is 4. Next up is ID 2. This ID. I will ask, my map contains ID 2. Map will say, yes, I have. So what will I do? I will compare what is the value, current value of this ID 2. Value of ID 2. So it will return me 4, right? I will compare with the price I. Current price of I is what? It is 5. If this 5, if price I is less than this map dot get, if this value I find it less than map dot get this current ID of I, right? If that is the case, then I have to update that key value pair in a map. So I will put map dot put, the key will remain same, that is ID of I, and I will put it with price of I because that is the smaller amount. Otherwise you do nothing, you will move ahead. So in this case, I observe that 5 is greater than the current amount I have, so I will not update it. I will move ahead to the next iteration, that is at this index. I will ask, map contains 3. Map will say no, so I will add this key value pair where ID is 3 and price is 6. Now you are done with storing in your map. Now what? Whatever values you found in your map, just do the sum of them, and that is your total answer. 6 plus 4, 10 plus 3, 13. That is what you are going to return. Because we have stored the pairs in map in such a way that only distinct IDs are stored as keys, and the ones with a smaller price will be stored in their value. Now, one more example, I'll take a hypothetical example. For example, I have a key value pair 1, 2, this is IDs 3, 3, 3, and 4. Let's say these are your IDs. One last example for this question, because this question is very simple and code is also going to be really simple. So let's say the prices are 3, 4, 8, 1, 3, right? 10, and then what I have, let this be 4, and then I have price maybe 5. Okay, these are the prices. Now, how will you store in your hash map? So your map will contain key value pairs, the distinct keys, and the values will be, in case of similar IDs, the smallest value will be stored for that ID, right? So I will ask, 1 is present in my map. Map will say no. So 1 will be added. Okay. 1 will be added with value 3. 2 will be added with value 4. When I come at 2, 8, it will see that 4 is already small, so I will not update. Move to the next one. 3, 4 will be added. Move to the next one. 3, 3. 3 is smaller, so this will be updated. A new key value pair will be, means key will remain same, value will be updated with 3. Then I get 3, 10. 10 is greater, no, it will not update. Then I will come at 4 and 5. The total amount that you will have to pay will be the sum of all the values. 5 plus 3 plus 4 plus 3, right? That will be 16. That's all. Okay, so now I think it's clear to you, as I can see in the chat as well. Moving on to the next problem. Before that, you can have a look at this code. So we created a hash map. We are iterating over items array, these ID that I was calling as ID array. So this items array, I'm asking my map if it contains already, store the value, the minimum value of all the IDs, similar IDs that you find. Otherwise put in your hash map. That means you have not found so far. Then you iterate over the map dot values and add them to get the final answer. Understood? Shall we move to the next problem now? Giving you 10 seconds to just have a look at the code, and then I'll be moving to the next problem. Occurrences of 1, 0, 1. So this is also a nice question. Not too difficult one. Actually easy one only. So occurrences of 1, 0, 1. Moving on to this question. Okay, fine. Next question. So this question says that you are given an integer n, okay, and you have to count the number of times the sequence 101 occurs as a subsequence in the binary representation of n. So let's take example of 21. What are we going to do in this question? The result is 4. So 21 in binary can be represented as, 1, like you see here. Let's take this example. Binary occurrences of 101. occurrences of 101. So you are given an integer n is equals to 21. Its binary representation is 10101. Is that right? Yes. Now you have to tell how many subsequences of 101 are occurring in this binary representation. So if you observe closely, subsequence, need not to be continuous, right? So it can be at different places, but the sequence should be 101. Now let's check wherever can we find. So if I take this one, this 0 and this one, I get one subsequence from here. Okay, I will just highlight the number whenever I'm trying to write the subsequence with green. So this is 10101. Let me just write it 4 times so that I will show you the solution. 10101. Now let's see what subsequences we are finding of 101. So one subsequence is, write this, 1 0 and 1. Okay, other subsequences 1 0, and is there any other one apart from this one? Because this we have already taken. Yes, there is one more one, which is this. Okay, now let's take, if I take 1 0 and these ones are already taken, so let's move to this one and a different 0, which is this 0 and this one. Okay, now if I take same one and same 0, then there is no distinct subsequence I can find. Let's try to take another one, which is this one. Now this is 0 and this is 1. So these are the only possible 4 subsequences of 101 I can find in this string. I hope the question is clear to you. The ones that I've marked with green are actually the subsequences that we are taking into consideration for our answers. Fine. How to solve this problem? See, this is also very good and nice thing to do in this question. I'll tell you what can we do. So what are we trying to do in this question is that for the sequence binary representation, whatever you have, right, I am trying to iterate from I equal to 1 till I equal to last index minus 1. That means I start from here until here. So if maximum I can go till 64 bits, right? According to indexes, it will be 0 to 63. Since I told you I'm starting from index 1, so the last I can go is still 62. So I will take my I less than 63. Got it? And what I'm trying to do is I will check if that ith bit, if my ith bit in that sequence that I'm trying to find is 0. Basically what I'm trying to do, I'll find a 0, and to its left how many ones I find, and to its right in that binary representation how many ones I find. That will be my target, right? If I know how many ones are there, I can know the count of the subsequence I can get. You got this point? So what I'm doing is, let's start over this 101. This is 10101. Let's say my I is at, this is 0th index 1, let's say 3 4 5. Let it be like this 0. Okay, but fine, let's start it like this, not literal indexing as we do in arrays. I hope you're understanding the point. So 5. Now I start from this index. I check if this index is bit is 0. So ith bit, how can you find if ith bit is 0? Very simple. Manisha Kumari, we have already started. I think there is some issue with your maybe internet. We are already discussing second question. Okay, so how will you find in any number? How do you find if ith bit is set or not? We have already done this thing a lot of times. We simply try to either right shift that number, and I'm telling you, we either do one thing, you right shift your number and do a bitwise AND. So if I right shift this number by how many times, maybe either you can do one thing. See, what we have done is we are right shifting that number by I times. So right now my I is 1. So you right shift your number I times. So what will you get? You will find a 0 here, right? And you will get a number like this, 0 1 0 1 0, right? This is how you are going to get your number. Then what do? We are doing one and bitwise and of n with n. This thing I don't think I need to stress much on this. The target is to find if your ith bit at n is set or not. If it is not set, then I am going to the left. That is, my j starts from 0 till I, right? Means I minus 1th index. I started I at 1. I'm checking if that bit is set or not. Basically, I think I've just written this. Let me tell you exactly what must be happening. See, One dry run over this test case and you will be able to understand what is exactly happening. 10101. So let's say I am at this index, right? I equal to 1. This is 0, 1, 2, 3, and 4. When I am at I, this is my I right now. When I am at I equal to 1, I am doing a right shift of this number by 1. So when I do a right shift of this number by 1, what I'm going to get? You get rid of this 1. Your 0 will come here. You will get 1 here, 0 here, 1 here, and you will get a 0 here. Now, next thing is you do a bitwise AND of this number with 1, right? So you get 0. That clearly indicates that this bit, that ith bit, is 0. So now my target is to check how many ones I have to the left of this bit and how many ones I have to the right of this bit, right? So for knowing this, what I'm going to do for left part, I will start my j. Let's say j starts from which index. Either you can do one thing, you can, this is your I, j can start from I plus 1 and j can go less till 63rd bit, right? This is where your j starts from this index, which will be I plus 1, and can go till the last index, which is less than 64. That is maximum, it can be 63. So this way you can find how many ones you have in the left part, and again it will become like a new question for you. So basically you are finding in this question, in this binary representation, how many ones you have. So each time, for each j, let's right shift this number, or however you want to do. Let's right shift this number by one index every time and find if that bit is set or not. Okay, and you do a bitwise and same thing. How many you basically have to find how many ones you have in this part of sequence and how many ones you have in this part of sequence. And how you can do, you already know how do we find if a particular bit is set or not, right? I will show you that also. So when you do, so your iteration for this part will go from j equal to I plus 1 to j less than 64, and for this part your iteration will go from, you can take any other index and j, otherwise j also, because these are two separate loops. This part, your j will start from 0 and j will go till I minus 1th index. So I was 1, so it will start from 0 and remain at 0. Fine. So now tell me, if I find two ones from left part gives me two ones and right part gives me one. So what do you think should be my answer in this case? Right part for this 0 gives me 1. Now when so how many answers I will have? This 1 and there is 1 0 and 1 you found here. Good, Aryan Pawan got it right. We will get L into R times. Why so? See, just for people who do not understand, this is the 0 I found, and these are the ones I found from left part, and this is the one I found from right part. So this one can connect with this one to form 101. This is one case. Other cases, this one can connect with this one to form number subsequence. So that will be left answer multiplied by right answer. That is 2 into 1 equal to 2. Now, since we are running a loop, I told you our bigger for loop is starting from I equal to 1 and I less than 63. I told you the reason. And this bigger for loop will be finding the number of zeros at each index, number of 0th bit on each index. Now the next 0 I will find will be at this index. Again, the question will remain, left part of it will return me 1, that is I found 1, only one set bit, and right part will give me 2, that is I found from right, I found two ones present in the right part of this sequence, this 0. So how many subsequence can I find that will be left into R? That is 2 from here. So these will be added, the number of subsequence I found due to this 0 plus number of subsequences I found due to this 0, that will be 2 plus 2 equal to 4. That is exactly our answer. Let me know if you have any doubts in the explanation. You guys can now see the code. I will explain to you exactly what I discussed. And if you have any doubts in the explanation part, just write it in the chat. I'll take that thing over again. Okay. So see, as I told you, bigger for loop starting from I equal to 1 less than 63. That is 62nd bit. Why? Because I have to take left part also and I have to take right part also. Fine. Understood clearly? Good. Then this is how we are doing I hope this is clear to you, because if this is not clear to you, then you may be confused what is happening here. So we are simply right shifting the number by I position so that I can find if ith bit is 0 or not by doing bitwise AND with 1. Okay, sorry. If that is the case, if it is true, then let's start our iteration. Let's check for L. Left, L is representing my left part, R is, so these will be storing number of ones from left and number of ones from right. So my this for loop starts from j equal to 0 and goes till I. That is basically, it is giving you, see, these L and R might differ in my explanation in this, so you can do it on your own, whichever way you want. Okay, so I think people have understood it, so I don't need to stress more on this code. Let's move to the next question now. If still you have any doubts, I'll give you 10 seconds. You can write in the chat. Okay, stopping here until we move to the next part. Okay, so let's go ahead to the next problem. If you guys have understood it, I think this thing is clear. Exactly what I said, that's what has been coded. Try to dry run on your own, you will understand it better. It's a simple one. Fine. So your next problem is whether to judge or not. So let's have a look at this question. Okay, so this question is also not a difficult one, just some play arounds with the language that you are using in your code. Okay, just few of those things you have to keep in mind. Logic is very simple. Let me just tell you now. So this question says a geek is conducting a, this is the thing what we want to do. Let's say geek wants your help to avoid judging too frequent submissions. We have to implement the, so in this question what you were given only this function that you wanted to complete and only this function that you had to complete. These are the functions we have written for ourselves for this question. Basically you had to complete this and this. What they're saying that you are given a constructor whose argument is cap. Okay, that tells you it accepts a single integer k, which denotes that a user's submission is judged only if he has made any submission in the past or has not made any submission in the past or made a submission at least k seconds ago. That means, I will explain to you. First, let's go through this part. Then second is judge or not. This function accepts a submission ID in the argument, which returns true if it is required to judge the submission, otherwise it will return false. And the ID is represented, any ID is represented as the user ID separated with at the rate and the time step that represents the time at which that person has submitted the problem. So if I check this test case, see, these are your function calls. In the constructor, it takes argument 5, which tells me that minimum, this is the time span that a person who has submitted the question has to take at least 5 seconds of time to make another submission. If the same person makes a submission within 5 seconds, then that submission will not be judged. That is what it says. And judge or not, these are the 5 arguments. 1 2 3 4 5. So 5 usernames you have and their timestamps you have with the different timestamps. Now let's see. What you have to return? You have to return if that person's submission will be judged, then return true, otherwise false. So first up we have Paris with this timestamp. So there is no other Paris so far. I will return true that okay, we will judge its submission because there is no constraint here. Then we have different user ID. We will return true for this also because there is no constraint. The constraint is what? I hope you know, but I will tell you when we comment this. Now we have another user ID with a different timestamp. This person's submission will also be judged. When we get a username who has already submitted previously, the same username person I have gotten earlier, now how I have to judge? Your judge or not function will check what is the timestamp of this person and I will compare it with the timestamp of this person with the previous submission. If the timestamp difference is greater than or equal to 5, only then I will return true for this submission. So if I check timestamp of his previous submission, that is 8/1/12, right? That is 8 hours, 1 minute and 12 seconds. And this submission is 8 hours, 1 minute and 16 seconds. So the gap between the two submissions is only 4 seconds. 16 minus 12, 4 seconds. And this constructor has given you already cap as 5. That means the difference has to be greater than or equal to 5 seconds. Only then that submission will be accepted. So this will return you false. Now let's come at next user, Paris. That person has been found previously also. So let's check his timestamp now. So this timestamp difference is exactly 5 seconds. So now I can return true because 5 seconds is allowed. Where this cap represents that this is the minimum time gap that a same person should take for its next submission. The different person submissions will be allowed and always return true. Now, one more thing to note, the submissions will be given in the increasing order only. That means if this person has submitted at 8:1, next person's submission will be greater than or equal to this timestamp only. And if 000 is appearing after, that means this is the submission on the next day. Okay, don't get confused. Whenever you find such a submission after this person, in this case, if you see, you will find seconds less than this seconds, but that can be added as a +1 hour. Okay, +1 day. So I hope the question is clear to you. Now let's see, very simple thing in this question also we have done. So what we have done in this question is, see guys, we have taken a hash map, okay, and this capacity in the class GFG, this constructor was given. So I just initialized these values in the constructor. Basically, okay, to this hash map, I gave the memory to this hash map. Now coming on to our judge or not function. Since we are doing it, I'm doing it with Java, I'll explain you what has been done here. We can use submission ID is of type string. Okay, I'll just tell you here. So in this judge or not function, you are given a string. Okay, let's say str or submission ID, and this submission ID is type some string here. Then it is separated by, means then there is an @ and there is some timestamp, right? So whenever I use any str.split and I give some character here, so what Java will do, that it will divide this string into two parts, one which is to the left of this key that I have given. Since I have given this split @ that means to the left of this character, that part will be taken as one part of the string, and the right part after this @ will be taken as second part of the string. And I can access them as, let's say this is new str. So new str will have string divided into three sections. One is this, other one is this @ and the one is this. So I can take new str 0 will be representing me the left part of @ which will be basically the name of that person, user ID, and timestamp will be represented by new str of 1, which is this is 0th index, this is first index. This is what I'm doing. I am splitting my string into two parts, one to the left of @ other one to the right of @. That is how dot split works in Java. And this will return me the timestamp part that will be of type hour, minutes, and seconds. Now, what I'm trying to do is, see, I got the username from the dot split 0th index and timestamp from the dot split first index. Got it. Now, next thing is, I am taking a hash map which will be using these as key value pairs. Key will be the username and value will be the timestamp. Now, if my map already does not contain that user ID, let's say, okay, if that is the case, that means definitely I can return true. And the second condition is I check if that already exists. I give some timestamp and the capacity. I check if that person is already existing in my hash map. Then I will check on which factor, if the timestamp of his current submission is greater than or equal to k, by means the difference of the current with the previous should be greater than or equal to k. If that satisfies, then I will add into my hash map that particular value and return true. Okay, this is what we have done. Now, if you see this check function, so what are my conditions? First condition that I've taken here is, if your map does not contain that username, okay. And the second condition I have taken is do its OR with this condition. This condition is checking what? If let's say that map already contains that particular username, then I am passing what timestamp does that username consist of. For example, Paris, take this example, 810. I'll show you how we are storing this in map so that you can understand it better. So what must be happening now, what I'm doing in judge or not function, that I am taking a map, okay? In my map, Paris is present or not? No, it's not present. So a key value pair will be added whose name will be Paris, and time and key value pair will be the timestamp. But I am converting each timestamp into seconds. Into seconds. Why? So that I can easily get the difference of the seconds I have. So if I have to convert this 8 1 12 into seconds, how will I get? I will do 12 plus minutes. How do you convert minutes into second? That 1 into 60, 1 equal to 60 seconds, plus 8 hours I have to convert it into seconds. So 8 will be converted to seconds by 60 into 60. Okay, I think, is that fine? Fine. So that's what we are doing, and finally it gets converted to seconds, how many seconds it will be there. So key value pair will be like this. Let's check this. What is the first one? Let's check it. 3600 8 16800, whatever it is. Then I have 60. Then I have 12 2716872. For example, Paris will be stored with 16872. Then I will have Ayush. Map does not contain Ayush already. So a new key value pair will be added with username Ayush, and timestamp will be converted into the corresponding seconds, which will be greater than this by how much? Just 1 second. So this will be, let me write it properly because we have it. Let me write it nicely so that you can understand it, although I'm sure you must have. I think, I think I made some mistake here. 28800 60 and 12. That should be the answer. 28872. Let me write it properly. 28872. So Paras will be 28872. Ayush will be in seconds 28873 because there's difference of only 1 second. Now next iteration will be for Naman. Naman will be stored with what? His name as the key, and value will be what is the, it is also taking the same time submission, but since he's a different user, I will accept his submission. Next up we have is Paras. So I will ask, my map will ask, is Paras already present? Map will say yes. Then next factor is I am writing a new function check, which is taking what is the current timestamp that I have in my map for Paras, that I will take as argument. So it will be this. Then I will take the current argument as current timestamp as another argument, which is actually how many seconds? 4 seconds greater than this. So what seconds will go here? The next argument will be 28876, right? And the other argument that I am taking, you can see it here. See, when I am checking, I'm writing this check function. So this is the case when I already have that user ID in my map. So it takes the current, it takes what is already the timestamp that was previously used, the current timestamp, and I will take a capacity, the gap. That means maximum, what should be the time difference between both. So what I'm trying to do in this function, you can see what we are doing. We are taking last submission time in seconds, current submission time in seconds. Basically this function is converting your time into seconds, and you can do it either way. See, in the solution, map is taking keys as person, and the value is exactly the timestamp only as string. And then in this part, I'm converting that timestamp into seconds using convert to seconds method in Java. Fine. So this convert to seconds will directly convert this timestamp into values like this, which I have written here. And map will originally will be storing the string only. So you can take map of type string only like this, so that it takes username and here it takes timestamp. So when you go to the check function, you convert them into seconds. If by chance you find a timestamp like 000, that means if it is less than this, it cannot be less. If it comes out to be less, that will be the case. If it is 000 something like that, that means you will add 1 day to it. So 1 day in seconds is 86,400 seconds. So you will add this value to the current timestamp so that you can get the exact difference, and you return this submission in seconds minus last submission in seconds greater than or equal to cap. If that is true, you will get true, otherwise you get false. So if this function returns you true, okay, then you add that username with the current timestamp into your map and return true, otherwise you return false. That is exactly what we are doing. So this convert to seconds method also, instead of taking the inbuilt method, we are actually converting it as simple as what I told you. You are passing that timestamp, you're passing the timestamp is of type string, and that string is divided by these colons at two different places, at this place and this place. When I take integer dot parseInt timestamp dot split this 0, that means it is trying to take this part, and then first index is taking this part, second index is taking this part. That is what we have taken. So these int values we are converting to seconds by using this formula. That's about it. So here you have, this is nothing but mathematical calculation. I hope you understood this by now. If you have any doubts, just let me know. Guys, if you have any doubts, let me know. I think it's pretty clear. If at any part you find any doubt, let me know. Otherwise, I'll move to the next part of the question. Please write in the chat. Shall we move to the next problem now? Okay, 53rd line. Let me check it. Okay, so this line is representing this. For example, now you know that timestamps have been converted to seconds. Okay, if let's say you have some timestamp like this 000000, and previous timestamp, let's say, was this, who's who in seconds look like this, right? Previous timestamp was this 0113. So this means that this represents 12 o'clock, right? But since your question says that the timestamps will always be in non-decreasing order, that means increasing only. So this means it is corresponding to the next day. So if it is corresponding to the 12 of next day, so basically I'm adding how much? We are adding some 1 day in seconds. This is what we are doing in this part. Okay, so that 1 day, how many hours you have, and if you convert them to seconds, how many seconds you will get. This is what we are doing, so that we get the exact amount in seconds of for that particular timestamp. Okay, let me know if you did not understand this part. Got it? Yes, right. That's the edge case. Got it. I think you understood it. Let me know if I can move to the next question now. Okay then, guys, moving to the next problem now. The next question is least beautiful box. So let's have a look at this question now. So what does this question say? In this question, we have an array of length n that denotes ID of the ith ice cream that Geek has bought to celebrate his birthday. Now, out of nowhere, he wants to divide them into different boxes such that in each box, the ID of the ice creams can be represented as sequence of consecutive integers. Voice is not audible. Let me check. Is my voice not audible, everyone? Can you tell me? Let me check. Is it audible now? Voice is audible? Okay, good. Yeah, coming back to the question, what is this question? Let's see, out of nowhere, he wants to divide them into different boxes such that each box represents the IDs of ice cream in the consecutive order, sequence of consecutive integers. Fine. The beauty of a box is defined as the number of ice creams present in that. Please help Geek to find an arrangement such that beauty of least beautiful box is maximized. What does this question say? Let's understand it. Have a look, everyone. Okay. So, what do you mean by least beautiful box? See, the Geek wants to divide the ice creams into different boxes of consecutive integers such that you get consecutive integers only. Now, what can be the box with the least consecutive integer? It can be just one element. So what he wants is that whichever box is left with the least number of ice creams, maximize the count of that box. How can we do that thing? So if you check 1, 2, 3, 4, I can divide it 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, and 5. These have been taken. Now let's take this one, next is this 2, next is this 3, right? Next is this 4. Now you see I've already divided the ice creams into two boxes and each of them have consecutive numbers. But what are the possibilities in which these ice creams could have been divided? There could have been a case like this also. 1, 2, 3, 4, right? And other one can be 1, 2, 3, 4, 5. So in this case also, the maximum number of ice creams I can find is 5. Okay, but you have to return the box with the minimum number of ice creams. So this will remain 4. In these are the two different, although these are basically permutations of each other. Let's check what are the other combinations possible. What if I do it like this? 1, 2, 3. Okay, or not, maybe like this. Let's do it. Are there other possibilities for this box? No, because you will not end up getting consecutive integers. If I try to take 2, 3, 4, then I will have 1, 2 for the other one. Let's say I'm just dividing, trying to make the combination help you understand what we have to exactly do in this question. I have used up 1 and 2 twos. Now I am left with 3, 4, 5. So 1, 2, 1, 2, 1, 2, 2, 1, 2, 2, 3, 3, 4, 4, 3, 3, 4, 4, 5. So, okay, one combination, one possible combination could have been this also. Getting it? One possible combination could be this. But what is the issue with this combination? That what is the minimum number of ice creams you can find? You can find two minimum number of ice creams. So what we did, he tried to maximize this box with the maximum amount he could have filled. So I just increased the count of ice creams with the consecutive integers. So what we want is that minimum box with minimum is to be maximized, divided in such a way if there is a possibility to get a box with even more number of ice creams, there must be one box with the minimum number of ice creams in whatever division you have made. Then that box with the minimum ice creams, can I still increase the count of ice creams for that particular box? If so, return the count of ice creams in that box which you just maximized. Okay, a little typical question, not a very easy question, but it's a good question. See, is the question clear to you? Now, if we take another example, n equal to 5, ID is this. We have 4, 5, 6, 6, 7. What arrangements can you choose? You could have chosen 4, 5 also. You could have chosen 5, 6. You could have chosen 6, 7, and then remaining would be 4, 5, 6. Right? This is like one of the case. Other case could be 4, 5, 6, 7, and 6. See, in this case, what could be the other combination? So what do you have is 4, 5, 6, 6, 7. One possibility would have been that you take 6, 7 in one box and 4, 5, 6 in one box. Other possibility could be that you take 4, 5, 6, 7 in one box. This 4, 5, 6, 7, and only 6 in the other box. But see, in this combination, the box with minimum ice creams is this box with only one ice cream. And what we did, we tried to increase the count of, we tried to maximize this least beautiful box. So for that, I increased one more ice cream here. Although one ice cream got reduced, it got reduced from the already present distribution. But still, this still remains the maximum. This still remains the maximum beautiful box, and the minimum beautiful box has been maximized now. I hope you got this question, right? So I should be returning 2 for this test case. Okay. So this is the question. I took some time to explain the question because that is the important part for this problem to understand. Now see, what are we doing in this question? This gives you a function minimum beauty which takes id of integers like this and total count of size of this array with n, right? Okay, what I'm doing is I am first of all sorting this IDs array. Why am I doing so? Just stay with me, you will understand. Then I am taking a hash map of integer which will be the count of IDs, means the index of ID, and a tree map of type integer in my hash map. Now what is a tree map? So a tree map, I am taking a tree map of type tree map of type integer. So tree map is also a type of a hash map which takes key values pairs, but in which keys are always present in sorted order. This is the tree map. Okay. So I am taking a map of integer and of tree map. Okay, that is the map I am taking. What is the tree map? So tree map is also a map of type integer comma integer here, which tree maps property is that whichever key value pair you add into it. For example, I add 0 and 2. I add 3, 1. Then I put 2, 4. No matter what are the values, I'm just focus on the keys. Then I add 1, 3. Now if you return, let's say I ask you map dot get whatsoever tree map, whatever it is. So if it was a usual map, the key value pairs, the way I have added them, they would have been stored in that order only. First 0, then 3, then 2, then 1. But tree map will actually sort these keys, and you will find 0, 2, then 1, 3, then 2, 4, then 3, 1. That's the order in which your tree map is going to store these key value pairs. Fine. Now let's see why we are doing this thing. Now in this loop, let me take this example. So I'm sure that you guys can see that we have used language Java here. So I hope that is evident that we are coding in Java. And just to be more clear, the questions that I discuss here are always in Java only. Fine. So whenever I take up any question, be it your codeathon contest or any other contest, or even the SD sheet that I'm taking every day at 10:30 p.m. So each of the questions are in Java. Fine. So let's see. Fine. This is the code that we have written. Let's see what we are doing in this. I hope this is clear to you, what we are doing with the map, how we are creating them. Let me write it here. Fine. I think it is still okay. Fine. Let's try to understand what is happening. First, we sorted our array. So our array was 513. Let me take this example. I'll just sort the array quickly so that you can understand the dry run over this example. This is 51322. This is the array that we are running over. So when I sort it, it will become 1, 1, 2, 2, 3, 3, 4, 4, and 5. How many are these? 1, 2, 3, 4, 5, 6, 7, 8, 9. Fine. Now we are creating a map of type integer and of type tree map. Fine. Now let's see what we are doing. Then we are iterating over int x belonging to id for each value present in your array, right? So this you have already sorted the id array, so I'll be now iterating over these elements. So when I'm iterating over first element, I ask if my map, now let's say this is your map, if your map it contains x minus 1, since I want to get an array of consecutive integers. So whichever element I am right now iterating over, I am asking if my map already contains the number which is 1 less than this. So when I check this condition, I should be having 0 in my map, but I do not have it. So I go to the else part. I go to the if hm dot contains key x minus 1. This is not true in this case. So I go to the else part. If now I ask my map if this current value is also present or not. If it is not present, now that is the case, 1 is not present. So you put this map and create a new tree map for this one. Why we are doing this, you will understand after few iterations. So basically 1 has been added and a new tree map has been created. New tree map, let it be like this, has been created for this, and hm dot get x, and in that tree map, since this tree map is also actually a map only, I am adding what? Hm dot get x. Okay, dot put means for one, what is the key value pair you're going to store for this. Basically it is a map of integer and map. Okay, so in this map I will be storing some key value pair. What is that going to be? So I'm going to put 1 as the key, and value will be hm dot get x dot get or default. This is the same thing if it is already not present, so I'm going to add 1. Okay, so it will be 1 1. This is how it is going to look like. Fine, this is your first that thing that has been added to your map. So hm dot get x dot get or default, whatever value was there, you add 1 to it. So there was nothing, so 1 against this 1 has been added. Okay, so this is your first. Next come to this iteration. When I commit this iteration, I ask if 0 is present. 0 is not present. Then I go to else part. If hm does not contain this key, then you are doing these things, but it already contains. So I do go to the next iteration. Okay, what is my next iteration? Now I am at 2. So it will ask hm is the map name that I'm creating of type integer and a tree map. Fine. Okay. Now actually this tree map represents that for 1, I got 1 occurrence of this one. Fine. already I got one occurrence of this one. This is a tree map, which will be adding it in its own way. You will understand how we are adding. Now when I'm at 2, my map already contains 1. So why will ask me hm dot get this 1. So this one will return me a tree map, and in tree map we have this method. Tree map has a method which is dot ceiling key, which tells you dot ceiling key, and whatever argument I give, right, whatever argument I am giving, this will return me value just greater than this argument that I am passing. So I want to know just greater value of -1 that I am finding so far for this hash map. So y will contain 1, right? So just greater than -1, because it can be 0 also. As you see that ice creams can be of type 0 till n, right? It can be greater than that also, but this is how your IDs of ice cream are going to be. So I'm just asking just greater value because I want to find the consecutive sequence. So I'm using this ceiling method. So in my map, for 2 I've got one less value, that is 1, and in its tree map, okay, for its tree map, what is the dot ceiling of -1? That is 1 itself, okay. So now for this one, I have already gotten a 1. This will be put for this way, hm dot get x -1. That means for 1, I'm going to put this y. Okay, so this tree map will have a new key value pair, which will be hm dot get x. It will be y, which is 1. It is already existing actually. Dot get x -1. So it is already existing. Now if hm dot get x -1 dot get y equal to 0, if that is 0, then hm dot get x minus, see, basically what you are doing, this is the tree map thing. It will get a little confusing because this thing you have to have a good grasp over tree map. Next thing is what we are trying to do in this question. Whenever we find a previous value, right, whenever we find a previous value, there is a possibility I can remove it from the current stack that I have or current map, so that I can add it to the new box. So for that case, I'm removing it. Fine, I'm removing it. So taking them into considerations, you are doing these things. Now you will check after removing, does your map contain this current value? If so, then add a new tree map for that current value and do the similar thing that we were doing and remove the things. I'll suggest you just do one dry run over this and you will understand how tree map is working for this particular question. Okay, and in the end you will find, for you want the minimum value of the possible combination that you made. So store minimum with the maximum integer dot max value. Now for map dot entry, map is of type integer and tree map e belonging to, we are iterating over each entry set, right? For each entry set, minimum equal to math dot min e dot get value dot ceiling -1 comma c. What we are doing is, so each entry set is associated with a tree map as its value. So minimum will be stored with what e dot get value gives you a tree map dot ceiling -1. That means the next consecutive element from which my box must be starting, that value, and compare it with the min. So whatever is the minimum, basically e dot get value dot ceiling -1, minimum of this, and already the minimum that you have. So you will have the minimum element for any box that you have taken into consideration, and you finally return it. Okay, that's what we are typically doing in this question. You'll have to go through each line and try to do a dry run if you are not already aware of hash map. If you are aware of hash map, I'm sure that it must be clear to you. No, if not now, maybe after you try to code it yourself, you'll be able to understand it. Okay. So that is your question. I'll check if you guys have any doubts. So what if in case, let me also explain if you are still in doubt.
tree map is doing what? Tree map is basically we are using it to store the counts of consecutive sequences of ice cream IDs. Basically, any possible combination that we are trying to do, that will be stored for that particular integer, that particular, for example, any sequence starting with 1. So it will be forming its own tree map, which is telling me what elements I have in that tree map, how many elements I'm going to have as ice creams. Okay, so tree map is used to store the counts of consecutive sequences of ice cream. Okay, starting with that ID, that specific ID that I am currently at while I'm iterating over the entire array. Okay, so that's what we are doing. By doing this, we are handling the consecutive sequences and updating our tree map up for consecutive sequences. Fine. And in the else part, we are handling, so these are handling your consecutive sequences, and your else part is handling your non-consecutive sequences. That is why we are creating, for that X, we are creating a altogether new tree map, which represents that I cannot add this integer to my already existing tree map as a consecutive sequence. That is why I'm creating a new tree map, so which tells me that maybe a new sequence can be started out from this X. So this else part is for non-consecutive sequences, and all the consecutive sequences are being handled here. Then we are trying to find the smallest count y in the tree map for the previous ice cream, that is x minus 1, updating the count for that in your tree map. Fine, for both previous and current ice creams. Okay, so if tree map for the previous ice cream, when we are removing it, becomes empty, then you will also remove it from your entire map. That's what we are doing. Fine. And if your ice cream ID does not have a consecutive predecessor, then you create a new tree hash map that is written in your else part of your question and start a new sequence from that X. I hope you understood this question. Then we are iterating over all tree map values and find the minimum value so that we can find the minimum beauty among them. That's the entire question. Fine. So guys, if you have no doubts, I will wrap it up. If you have any doubts, you can ask me. So I'd say questions were of moderate level only. This was a little good question, but if you have already done questions using tree map, then this was also of moderate level only, to be honest. So let's see if you have any doubts. If not, I will wrap it up. So I don't see having any doubts in the chat. Okay then guys, see you all in the next lecture, probably next coding contest discussion. Till then, take care. Bye bye. Thank you everyone.